Today, we're constructing a 4-foot by 8-foot mock-up of our STC Acoustic Sleeper system. We'll show how it's assembled and also perform a stress test on the system for moisture wicking. We're filming in the Rigidized Metals Design Center, an old freight house where the overhead doors have been replaced with glass. Rigidized Metals has been modeling ideas for new perforated metal ceilings that use our STC high Sabin panels for sound absorption, which you can see here. Looking at our wood frame mock-up, these 2x4s are 24 inches on center and represent 2x framing, trusses, or I-joists. The sheathing is directly applied to the framing members with fasteners spaced for lateral shear resistance. We're putting them at 8-inch centers, but structural requirements from the engineer may require closer spacing. A key requirement for installation is maintaining an 1/8-inch gap between the panel edges. This is for evacuation of any moisture that may get between the sheathing and the subfloor panels. Fire designs allow for this spacing, and panels are fabricated anticipating it. The bearing strips are used wherever load-bearing walls or shear walls are to be installed, so that there's continuity of solid structure to transfer the loads. The width of the strips should match the wall stud thickness. The thickness of the strips is determined to match the sum of the 1/4-inch high rubber pads plus the wood lath strips that are placed over the framing members in the next step. We're using 5/16-inch wood lath, which, added to the 1/4-inch pads, means the strips we're using here are 9/16 inches thick. Fastening frequency is not critical, since the walls that follow will be fastened all the way through to the framing member and hold everything together. We're using only a few, since we'll be taking this mock-up apart later to demonstrate the results of our moisture test. The acoustic sleeper pads take the vertical loads from the subfloor to the framing members. They're first stapled to wood lath strips at regular spacing, which are determined by the loads, as well as the thickness and type of subfloor panels. The reason for using the strips is to be able to easily see where the pads are located, so that they can be fastened through the sheathing into the framing members in the next step. The strips can be 1x2s or wood trim, such as stop-on jambs. We're using inexpensive wood lath to show that the system still performs even without the best quality wood. The strips are fastened through the pads with nails to the framing members. It's easy to see where the framing members are thanks to the fasteners used to attach the sheathing panels. We also know that they're 24 inches on center. The last step involves adhering the subfloor panels to the wood strips. The use of adhesive is much better than fasteners, which might cause squeaks. We're not actually applying the adhesive now, since we'll be taking this mock-up apart later for use in more tests. Once the panel is placed on the adhesive, just a few fasteners will hold the panel in place until the adhesive sets. Make certain that the length of the fastener is a length that does not penetrate the strip. Otherwise, there could be squeaks and sound flanking. We're using our mock-up of the STC Acoustic Sleeper system in wood frame construction to show how water that gets between the sheathing panel and subfloor panel is evacuated by design. We'll pour some water on the sheathing and then install the subfloor panel with a few screws. It's 10 days later and the moment of truth as we remove the subfloor panel. Even though we left only 3/4 of an inch of airflow underneath the mock-up, there's no trace of water on the sheathing. The water evaporates and becomes suspended water vapor, thanks to the gap between the panels and a physical process of differential water vapor pressure. The vapor evacuates through the gap naturally. No need to worry about trapped moisture with the STC Acoustic Sleeper system.